Okay, this is a second video for the Func G section of the functions module. And in this video we're going to look at the sketching technique. Okay, how we sketch a graph. Now the procedure to sketch graphs is determine domain restrictions or any asymptotes, identify the general shape, calculate the critical points. Now critical points are the y-intercept, the x-intercepts, and the vertex or the minimum maximum turning points. Determine the graph end behavior. So what does the graph do as x goes to infinity? What does a graph do as x goes to negative infinity? What does a graph do as it approaches vertical asymptotes? Okay, mark asymptotes and critical points on your graph and then draw an appropriate line or curve considering the end behavior. Okay, now note we are sketching, not graphing. So it's not going to be extremely accurate, but it's going to give you a general idea. Now we're going to look at exactly the same three functions that we did in the first part when we looked at plotting, so you get to see the difference between the two. So in this case I've got f of x equals a half x minus 3. I start off in the same way. I know that's a straight line. Okay, I know in this case that it's a positive gradient, so it's going to come up like this. So I have an idea of what's going on. I also know that because it's a straight line, there's no domain restrictions. Okay, now in this case, because I'm finding critical points, I do only find the intercepts. Okay, so in this case I find when x is 0 and then when f of x is 0. So when x is 0, I have f of 0 is a half times 0 minus 3, so that's negative 3, so that's 1 actual intercept. When fx is 0, I get 0 is a half x minus 3, add 3 to both sides, 3 equals a half x, times both sides by 2, and I get 6 equals x, so 6, 0. I then go straight to my graph, 0, negative 3, 6, 0. I don't have any domain restrictions, so I know when I join these 2 points that I'm going to put arrows on the end of my line because it keeps going. Okay, and then I'm going to label it f of x equals a half x minus 3, and I'm done. Okay, f of x equals x squared plus x minus 3. I know that this is a parabola. I know that because of the x squared term. It's positive out the front, so I know it's a happy parabola. And because it's a parabola, there are no domain restrictions. Okay, now for critical points, I can work out x and y intercepts. So x intercepts are when f of x equals 0, so I get 0 equals x squared plus x minus 6. I then can do the quadratic formula or factorize. To factorize, I get x plus 3, x minus 2. You'll know when that expands out, I get x squared. Take 2x plus 3x is x, and 3 times negative 2 is negative 6. So x plus 3 equals 0, x equals a negative 3, x take 2 equals 0, x equals 2. So I've got negative 3, 0, and 2, 0. Okay, you could have done the quadratic formula there. It's up to you. Y-intercept is when x is 0. So f of 0 is going to be 0 plus 0 minus 6, which is simply negative 6. So my point there is 0, negative 6. The other thing that I need to find is my vertex or my turning point. And that's given when x is equal to negative b over 2a. Now from here, I know that a is in front of the x squared, so is 1, b is in front of the x, which is 1, and c is negative 6. So come back down, negative 1 over 2 times 1 is negative a half. So that's my first point, and then I plug it into my original function. So f of negative a half is going to be negative a half all squared, take a half, minus 6. Okay, so, and that will give me negative a half all squared is a quarter, minus a half, minus 6, and that gives me negative 6 and a quarter. As an improper fraction you can convert it, but that's going to help me for graphing. So my vertex is negative a half, -6.25. Now note, before when I was doing the plotting, that I said the vertex was at -0.5. So you can see that. So these are my critical points that I'm going to go to my graph and plot. So -3, 0, 2, 0, and -0.5, -6.25. Be about there. Oops. About there. And then I join, y-intercept, 0, -6. Join the dots. And there's my graph. Okay, now make sure your points, critical points, are labelled clearly. If these weren't on exact values, then I'd write them. I also need to write my turning point, or my vertex, which is -0.5, -6.25. Okay, and you can see that I have already labelled my axes. I think this is much easier. Last one. Now I kind of did this by the whole sketching technique before anyway, so we'll just quickly go through it. I know it's a hyperbola, so, and it's a positive hyperbola, there's a positive out the front, so I know it's going to, the basic graph is like that. So I get a general idea of the shape. I know that x minus 4 can't equal 0, so therefore x can't equal 4. That's an asymptote. I also know that if I swap these around, I get x minus 4 equals 3 over f of x, which tells me that f of x can't equal 0, and that's an asymptote. Now, because my asymptotes are at 4, let's line that up a bit better, x equals 4 and f of x equals 0, I know I don't have any x-intercepts, but I will have a y-intercept. So my y-intercept is at x equals 0. So f of 0 is 3 over 0 minus 4, which is -3 over 4. Okay? So I go and put that on my graph. 0, -3 over 4 is going to be about there somewhere. And then again, it's just a sketch. Okay? Make sure you don't touch the asymptotes, but it is just a sketch. And I put that point is 0, -3 over 4, and I label. Okay, now in terms of what happens with the end behaviour, I already know that an asymptote goes like this, so I haven't discussed that in detail. It is given in your textbook though. Okay. What now? We'll complete function G1 using this sketching technique and see how you go.